Students, very good afternoon. Today we are going to discuss about properties of Jacobians. Okay, properties of Jacobians. We are going to discuss about properties of Jacobians. So our first property is called inverse property. Our first property is called inverse property. First property is called inverse property of Jacobian. Okay, inverse property of Jacobian. Second property is chain rule. Second property is chain rule property. Okay, because we are going to use chain rule. Chain rule property, and we are having and third property is dependent function of dependent function dependa dependa de dependent dependent functions of dependent functions of independent variables. Okay, inverse property, chain rule, dependent function of independent variables. These are the three properties we are going to discuss. The first property, the first property says dou of u comma v divided by dou of x comma y, dou of x comma y into dou of x comma y divided by dou of u comma v equal to 1. So what does it mean? If u and v are the functions of x and y, if suppose I take u equal to f of x comma y and v equal to g of x comma y, 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 and we will have this property. If suppose I take the first Jacobian as J1, that is, this implies if I take first Jacobian as J1 and its inverse, that is dou of x comma y divided by dou of u comma v, J2, and if I take this inverse as J2, then J1 cross J2 equal to 1. So this is our first property. Our second property, that is chain rule property. So chain rule property means if suppose u comma v, v are the functions of x comma y, and if x comma y are the functions of r and s, x comma y functions of r and s, that is u equal to f of x comma y, okay, comma v equal to another function but function of x and y, okay, f of g of x comma y, g of x comma y, and both x and y are functions of some other variables. That is, x is the function of, or example, if I take psi of r comma s, and y is also a function of r and s, so I am writing as gamma of r comma s, okay, gamma of r comma s means then we will have dou of what we will have, numerator dou of u comma v, okay, divided by dou of x comma y, okay, dou of u comma v divided by dou of x comma y, because u and v are the functions of x and y, into but this x and y are the functions of r and s, so we are having dou of x comma y divided by dou of r comma s, means then we will have dou of u comma v divided by dou of r comma s, dou of r comma s, okay. So after this we will have, okay, so here we are having dou of u comma v, so I shall mark this. If u is first property, if u and v are the functions of x and y, then we will have dou of u comma v divided by dou of x comma y into dou of x comma y divided by dou of u comma v equal to 1. So that is our first property, and it can be also mentioned as j1 into j2 equal to 1, where j2 is the inverse of j1. That is, if j1 equal to dou of u comma v by dou of x comma y, then j2 will be dou of x comma y divided by dou of u comma v, and a product is equal to 1, okay. And a part is equal to 1, okay. Now here I have said this is a chain property, so it can be expanded to 3 variables also. That is, if I am writing it as dou of u comma v comma w divided by dou of x comma y comma z into dou of x comma y comma z divided by dou of r comma s comma t, means we will have dou of u comma v comma w divided by dou of r comma s comma t. That is, we have to imagine that these x and y and these x and y are getting cancelled, and these xyz and these xyz are getting cancelled. But actually we will not cancel those two terms, okay, because they are operations. The first x comma y is the denominator of first part, that is dou u by dou u comma v divided by dou x comma y. That is the first part. There we are having such denominator, and in the next part we are having dou of x comma y divided by dou of r comma s. There in the numerator we are having dou x comma y. So those two things are belonging to different part, and there are some operations, they are partial differential operations, okay. So we should not cancel those things, but we have to assume in such a way to derive the chain rule, and to make use of the chain rule property, we will get the final result, and by making use of chain rule property we will get a final result. Dou u by dou u comma v divided by dou r comma s for the functions of two variables, for composite functions of two variables, and for composite function of three variables we will have dou u comma v comma w divided by dou r comma s comma t. Now we are going to see one important topic, that is functional dependence. Okay. Functional. So functional, functional, functional dependence. Under this functional dependence only we are having their property, okay. Functional dependence, okay. So what is minimum functional dependence? I shall tell you the explanation. You have to make use of that, you have to write it as your notes. So if u equal to function of x and y, okay, for example u equal to f of x comma y comma v equal to phi of x comma y, okay, u equal to f of x comma y and v equal to phi of x comma y. So these two are functions of x and y, but they are two differentiable functions of the variables x and y, two differentiable, okay, they are differentiable functions, okay. And also we are having, you have to write, and if these functions u and v satisfy a relation, okay, satisfy a relation, and the relation should be of the form f of u comma v, that is capital F of u comma v equal to 0, where this capital F is differentiable, and so if it is differentiable means you will have dou u by dou x, okay, comma dou u by dou y, comma dou v divided by dou x, comma dou v divided by dou y are not all 0 simultaneously. So they some derivative will become 0. The condition is these derivatives will not become 0, simultaneously. That is, at the same time all these four derivatives will not become 0. So at one time one derivative will be 0, at some other time another derivative will be 0. So depending upon the problem, we will have some derivative as 0 or some 2 or 3 variables as 0, but not all 4 derivatives will not become 0. Okay, so that is the important concept here. Okay, then these functions u and v. So what functions? These functions u and v are said to be functionally dependent, so u is a function of x and y, v is a function of x and y. These u and v are the differentiable functions of two different variables x and y, such that capital F of u comma v, where this capital F is also differentiable, and we are having capital F of u comma v equals 0, where dou u by dou x, dou u by dou y, dou u by dou x, and dou u by dou y are not all become 0 simultaneously, means then these u comma v, then these functions of u comma v. So functions of u comma v means that is capital F of u comma v, the functions of u comma v, the functions these functions u and v, that is these functions u and v means these functions u and v means that is these functions u and v. Okay, these functions u and v are said to be functionally dependent. These functions u and v are said to be functionally dependent. U comma v are functionally dependent. Okay, functionally dependent. Okay, functionally dependent. Okay, then if I extend it to n variables, that is if suppose u1 equal to f of x1 comma x2 comma etc comma xn, okay, etc comma xn, etc comma xn, and u2 is some different function f2 of, so I shall put it as f1, and here if I have f2 of x1 x2 etc comma xn, x1 etc comma xn, okay, comma etc. So finally we will have un will be a function of fn of x1 comma x2 comma etc comma xn, etc comma xn, and they satisfy the relation, and if they are said to satisfy a relation, capital F of u1 comma u2 comma etc comma un, etc comma un equal to 0, where this capital F is differentiable and not dou u1 by dou x1, okay, dou x1 comma dou u1 by dou x1 extra comma dou un divided by dou xn. So and if I extend like this, if I goes on extension like this, dou un divided by dou x1 comma dou un divided by dou, here it is x2, dou x2 comma etc dou u there it is u1, here it is u1, here it is u1, okay, here it is u1, and here it is dou un divided by dou xn, and here not all these partial derivatives are zero simultaneously. These partial derivatives will not become zero simultaneously, means then the functions u1 u2 etc comma un are called functionally dependent, okay, functionally dependent, okay, functionally dependent. So this is the introduction to functional dependence, by which we are having our clear property, that is dependent function of independent variables. So statement is, you have to write if u comma v comma w, if u comma v comma w they are functionally dependent, if u comma v comma w are functionally dependent functions of three independent variables x, y, z, okay. So these are dependent variables, these are independent variables, and these three are functionally dependent, okay, functionally dependent functions, okay, three functionally dependent functions, okay, these two are independent variables, okay, this is just arrow, functionally dependent variables, okay. Function dependent functions UVW, here x, y, z are independent variables. If so, then we will have small f of, that is function of any function, okay, that is function of okay, so okay, I shall directly explain result. If u, v, w are the functional dependent functions and x, y, z are three independent variables, and u, w are the functional dependent functions of three independent variables x, y, z, then we have the result dou of u comma v comma w divided by dou of x comma y comma z, equal to 0, x comma y comma z equal to 0. So these are the three important properties of the Jacobian function, okay. So I hope you all understood these important properties, these three important properties of Jacobian. So tomorrow we shall meet on the problems of Jacobians. Thank you all for watching this.